Hi everyone. Today we'll be talking about x and y intercepts. Here's today's FLT. Given a function, I will be able to find its x and y intercepts. So what are our x and y intercepts of different types of functions? The x-intercept is where the graph of a function crosses the x-axis. Here are some random graphs with their x-intercepts. What do you notice about the coordinates? So if you noticed, the y value of all the coordinates of any x-intercept is always 0. So our x-intercepts happen when y equals 0. So in order to find x-intercepts, we set y equal to 0 and then solve for x. Again, we set y equal to 0 and then find x. The y-intercept, which you're probably actually more familiar with, is where the graph of a function crosses the y-axis. So here are some random graphs, and take a look at the y-intercepts. What do you notice about the y-intercepts? Your y-intercepts occur whenever x equals 0. So you can find your y-intercepts when the x value is 0. In other words, to find the y-intercepts, set x equal to 0 and then solve for y. So to find the x-intercepts, you set y equal to 0. And to find the y-intercepts, you set x equal to 0. So let's take a look at some examples together. For our first example, we are going to find all intercepts of the function f of x equals x squared plus 4x plus 3. And f of x is just another way of saying y, so you could think of this as y equals x squared plus 4x plus 3. Finding the y-intercept tends to be a lot easier, so let's focus on that first. We're going to find the y-intercept. So when does this function cross the y-axis? We could find this by setting all x values to 0. So we'll have y equals 0 squared plus 4 times 0 plus 3. And let's simplify this. So 0 squared is just 0. Plus 4 times 0 plus 3. Next we multiply. So 0 plus 4 times 0 is just 0 plus 3. 0 plus 0 plus 3 is 3, so y equals 3. When x is 0, y is 3. So our y-intercept is the coordinate 0, 3. We found our y-intercept. Now let's find the x-intercepts. So the x-intercepts are the points where the graph crosses the x-axis. So the x-intercepts happen when y is equal to 0. So we're going to set this f of x, or think of it as y, equal to 0. We have 0 equals x squared plus 4x plus 3. And how do we solve for x from here? We're going to try to factor by exhaustion. So I'm going to go a little bit quicker here, but if you need a review, we'll give you the link to the past video about factoring. All right, so x squared breaks down to x times x. 3, the only factor pair is 3 times 1. So if we factor this, we get 0 equals x plus 3 times x plus 1. And from here, we can use the zero product property. So we're going to use the zero product property to solve for x. Notice we have two options right here. Either x plus 3 equals 0 or x plus 1 equals 0. So we're going to use the zero product property. Let me write it over here so I have more space. We're going to have two solutions. So x plus 3 equals 0 or x plus 1 equals 0. And we're going to solve for x for both options. For this first one, I subtract 3 on both sides to isolate the x. This cancels out, and I'm left with x equals -3. So this is going to be one of my x-intercepts. So we set y equal to 0. We found that x equals -3. So one of our x-intercepts is at -3, 0. But we have another one. For this second option, I subtract 1 on both sides. This cancels out. I'm left with x equals -1. So when y is 0, another solution is that x is -1. So I have another x-intercept at -1, 0. So I have two x-intercepts at -3, 0 and -1, 0. And as usual, we can use a graph to check our work. Notice how there are two x-intercepts at -3, 0 and -1, 0. And then our y-intercept is at 0, 3. Make sure you don't confuse the x and y-intercepts. The x-intercepts are where your graph crosses the x-axis, and your y-intercept is where your graph crosses the y-axis. Our next example is pretty similar. We're going to find all intercepts of the function f of x equals x squared plus 7x minus 18. So we're going to find the y-intercept first again, since that tends to be a lot simpler. So to find the y-intercept, we set x equal to 0. So we have y equals 0 squared plus 7 times 0 minus 18. 0 squared is 0, and then 7 times 0 is also 0, minus 18, and so this will equal -18. So when we set x equal to 0, y equals -18. So our y-intercept is at the point 0, -18. Again, we set x equal to 0 to find the y-intercept. Now let's find the x-intercepts. So when does this function cross the x-axis? We set y, or f of x, equal to 0. So we have 0 equals x squared plus 7x minus 18. And to solve for x, I'm going to factor this. X squared breaks down to x times x. And to get negative 18, there's actually quite a few factor pairs, so I'm just going to list them out. Again, if you have questions on how we got through this part, just let us know. And again, when you choose factor pairs, it might be a trial and error process, but don't worry. Okay, so I'm going to try 0 equals, let's see, x plus 9 times x minus 2. And let's make sure this is correct. We multiply the outside terms. X times negative 2 is negative 2x. 9 times x is positive 9x. If we combine these terms, so 9x minus 2x is 7x, which is that middle term in the original function. So we factored correctly. Yay. All right, so now let's use the zero product property to solve for x. So we're going to have two solutions for x. So either x plus 9 equals 0, or x minus 2 equals 0. Let's start with the first option. I'm going to subtract 9 on both sides. This cancels out, so I'm left with x equals negative 9. So I have an x-intercept at negative 9, 0. But I have another one, this option, adding 2 on both sides to isolate the x. This cancels out. I'm left with x equals 2. So my other x-intercept is at 2, 0. So we were able to find these two x-intercepts by setting y equal to 0 and solving for x. Here's the graph. So we have our two x-intercepts at negative 9, 0 and at 2, 0. And then our y-intercept is at 0, negative 18. Let's do another example together. Let's find all intercepts of the function f of x equals 2x squared plus 7x plus 3. So let's find the y-intercept first by setting x equal to 0. So we're going to have y equals 2 times 0 squared plus 7 times 0 plus 3. 0 squared is 0, so I have 2 times 0 plus 7 times 0 plus 3. And eventually you might not have to go through each step, but I'm just going over it just in case. All right, so 0 plus 0 plus 3 is 3. So our y-intercept is at 0, 3, because when x equals 0, y equals 3. And now that we found the y-intercept, let's find the x-intercepts. So we're going to set y equal to 0 and solve for x. So I'm going to have 0 equals 2x squared plus 7x plus 3. And we're going to factor this. 2x squared breaks down to 2x times x. And then 3 breaks down to 3 times 1. or 1 times 3, whichever way. I'm going to factor this. So 0 equals, and it's going to look like this, something times something. I'm going to go with 2x plus 1 times x plus 3. It's important to always check to make sure you factor correctly. We multiply the outside terms together to get 6x, and the inside terms together to get 1x. 6x plus 1x is 7x, which is this middle term we're looking for, the 7x, so we factored correctly. Now let's use the zero product property to solve for x. Either 2x plus 1 equals 0, or our other option is x plus 3 equals 0. Let's start with the first option, subtracting 1 on both sides. I have 2x equals negative 1. I'm going to divide both sides by 2, and I'm left with x equals negative 1 over 2, or negative 0.5, whichever. So I have an x-intercept at negative 1 over 2, comma 0. For the other option, let's subtract 3 on both sides. Cancels out. We're left with x equals negative 3. So our other x-intercept is at negative 3, comma 0. So like the other examples, I set y equal to 0 and found x in order to find the x-intercepts of this function. Here's the graph. Notice that we have two x-intercepts, one at negative 3, comma 0, the other one at negative 0.5, comma 0, or like negative half, comma 0. And then our y-intercept is at 0, comma 3. So for this next example, please try it on Edpuzzle. Find all intercepts of the function f of x equals x squared plus 6x plus 5. To find the y-intercept, set x equal to 0. And to find the x-intercepts, set y equal to 0. All right, let's look at example 5. Find all intercepts of the function f of x equals x squared plus 5x plus 2. So hopefully as you walk through more examples, you see the simplicity of finding the y-intercept. So again, we're just setting x equal to 0. So we have y equals 0 squared plus 5 times 0 plus 2. 0 squared is 0, and 5 times 0 is 0. We're left with y equals 2. So our y-intercept is at the point 0, comma 2. We set x equal to 0 and found y. Next, we're going to find the x-intercepts. But you're going to notice something when you try to factor. So when you try to factor this function, you're going to notice that you can't. There's no factoring option here. Oh no, yikes, what do we do? Well, don't be afraid, you can just use the quadratic formula. And in order to use the quadratic formula, we have to identify our a, b, and c values of this function. So a equals 1, B equals 5, and C equals 2. And I might be going through the quadratic formula portion a little bit quicker, so just let us know if you're wondering like, wait, how did she go from here to here? And we can also send you the video of the quadratic formula review. So as usual, we're setting y equal to 0 to solve for x. So it's going to be 0 equals x squared plus 5x plus 2. But since we can't factor this, we're going to solve for x by using the quadratic formula. Cue my favorite song.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, and then I'm going to plug in each value. So I have negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 2 all over 2 times 1. And let's simplify this. So it's going to be negative 5 plus or minus. So 5 squared is 25. And then negative 4 times 1 times 2 is negative 8. So 25 minus 8. And then all of this over 2 times 1, which is just 2. And let's simplify it a little more before we throw it into the calculator. So we have negative 5 plus or minus the square root of 17, because 25 minus 8 equals 17. And all this over 2. And since we have the plus or minus, we have two potential options. Either negative 5 plus the square root of 17 over 2, or negative 5 minus the square root of 17 over 2. And you can use a calculator to find this. They're going to be approximate values. So x either equals negative 0.438, or the other solution is negative 4.562. So we have two x-intercepts, one at negative 0.438, comma 0, and then another one at negative 4.562, comma 0. So let's take a look at this graph. Even though we use the quadratic formula instead of factoring here, it's still the same idea where to find the x-intercepts, we set y equal to 0. And then to find the y-intercept, we set x equal to 0 and found the point 0, 2. Let's look at another example where we're going to use the quadratic formula. So we're going to find all intercepts of the function f of x equals x squared minus 6x plus 1. First off, let's find the y-intercept. So when does the function cross the y-axis? We'll find out by setting x equal to 0. So we have y equals 0 squared minus 6 times 0 plus 1. We're just going to simplify this. Eventually, once you see the function, you kind of automatically see the y-intercept. In this case, the y-intercept is at 0, 1. We set x equal to 0 to find our y-intercept. Next, let's find the x-intercepts. So what is x when y equals 0? So we're setting this equal to 0. We have 0 equals x squared minus 6x plus 1. And we can't factor this. Oh no. But yay, the quadratic formula comes to the rescue. So let's label A, B, and C. A equals 1, B equals -6, and C equals 1. We're going to use the quadratic formula to solve for x. We have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. That song haunts me in my dreams. All right, so let's plug in each part. We have -6, we have a double negative, plus or minus -6 squared minus 4 times 1 times 1. Let me close the square root. And we have all of this over 2 times 1. Let's simplify this piece by piece. So the double negative right here turns into +6 plus or minus. And then -6 squared is +36. -4 times 1 times 1 is just -4. So we have 36 minus 4. And all this over 2 times 1, which is just 2. And then we have 6 plus or minus the square root of 36 minus 4 is 32. And all this stuff over 2. So we have two options, either 6 plus the square root of 32 over 2, or 6 minus the square root of 32 over 2. And again, you can use a calculator. I recommend using the Desmos calculator. I think it's pretty easy to use, and it's also like aesthetically pleasing. So we're going to get approximate answers, but x is either equal to, we have two options, 5.828 or 0.172. So we have two x-intercepts, one at 5.828, 0, and another one at 0.172, 0. So here are the two x-intercepts for this function. Here's the graph. We have two x-intercepts, and then our y-intercept is at 0, 1. For some examples, the function might already be factored for you, like this example. We have y equals x plus 4 times x minus 5 times x minus 1. So let's find the y-intercept first by setting x equal to 0. Make sure you're replacing each x with a 0. So we're going to have y equals parentheses 0 plus 4, then another set of parentheses, 0 minus 5, then times 0 minus 1. And then let's simplify what's inside the parentheses for each part. So 0 plus 4 is 4. 0 minus 5 is negative 5. And 0 minus 1 is negative 1. We multiply this. 4 times negative 5 times negative 1 equals positive 20. Our y-intercept for this function is at 0, 20. So even though it looks a little bit different, still the same idea of setting x equal to 0. Up next, let's find the x-intercepts of this function. So in the previous examples, we only had 2 x-intercepts. But here, we're going to have more. So to find the x-intercepts, we set y equal to 0. So we have 0 equals x plus 4 times x minus 5 times x minus 1. And notice since it's already factored, here we can actually just go straight into using the zero product property. We have 3 options here. X plus 4 equals 0, x minus 5 equals 0, or x minus 1 equals 0. So we have 3 solutions for x here. Let's find each one. So for this first option, x plus 4 equals 0, how do I isolate x? I'm going to subtract both sides by 4. We're left with x equals negative 4. So our first x-intercept is at negative 4, 0. For our second option, we can isolate x by adding 5 to both sides. Cancels out. We get that x equals 5. So our second x-intercept is at 5, 0. And then for our third solution, we find x by adding 1 on both sides. We solve for x and get x equals 1. So our third intercept is at 1, 0. So for this example, we found 3 x-intercepts. This means that the graph of this function is going to cross or touch the x-axis 3 times. And even though the format is different compared to earlier examples, it's still the same idea of setting y equal to 0 and solving for all potential solutions of x. So notice here we have our 3 x-intercepts. So the graph crosses the x-axis 3 times. And also our y-intercept is the point 0, 20. Let's do one more example together. Find all intercepts of the function y equals 2x plus 1 times x minus 6 times x plus 3. To find the y-intercept, we're going to set all the x values to 0. And again, the y-intercept is where the graph of this function crosses the y-axis. So we're setting x equal to 0. So we're going to have y equals 2 times 0 plus 1 then also 0 minus 6, and 0 plus 3. Let's simplify what's inside the parentheses. So 2 times 0 is 0, and 0 plus 1 is 1, so I have 1. 0 minus 6 is negative 6, and 0 plus 3 is 3. 1 times negative 6 times 3 is negative 18. Be careful about your positive and negative operations here. Our y-intercept is at 0, negative 18, which we found by setting x equal to 0. Next, let's find the x-intercepts. What makes this one easier is that it's already factored for us, so we can jump straight into the zero product property. We set y equal to 0, so we have 0 equals 2x plus 1 times x minus 6 times x plus 3. And using the zero product property, we're going to have 3 potential solutions for x. I'm going to fast forward this part to save time because this video is getting really long now. But if you need help, remember you can pause and rewind as necessary. So I'd recommend maybe pausing the video once here and kind of trying it on your own and then comparing your answers. Blah, 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 just skipping through, blah, 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 blah. All right, so hopefully you got these 3 x-intercepts. Our first intercept is at negative 1 over 2, 0. Our second intercept is at 6, 0. And our last x-intercept is at negative 3, 0. And if you have a question about how we got any of these, just let us know. And here's the graph. I know it's a little chopped off at the bottom, but we have our 3 x-intercepts, so where the graph crosses the x-axis, and our y-intercept is at 0, negative 18. So hopefully you guys were able to make a little bit of a connection between like the algebraic portion as well as the graph portion. And please try this last example on Edpuzzle. It's very similar to the past 2 examples we've done. And remember, you can use a graph to check your work, at least for now. So as a review, the x-intercept is where the graph of a function crosses the x-axis. To find the x-intercepts, set y equal to 0 and then solve for x. For today's examples, we mainly looked at like examples where you need a factor to solve for x, or functions where you need to use the quadratic formula to solve for x. The y-intercept is where the graph of a function crosses the y-axis. And to find the y-intercept, set x equal to 0 and then solve for y. Please remember to submit your notes on Canvas, and see you guys next time.